Hi, my name is Greg Batt. I'm an assistant professor in the Food, Nutrition, and Packaging Sciences Department at Clemson University. And I'm working on a collaborative research project with Purdue University in the development of what are called Triboelectric energy harvesters. If you've walked across your floor, a carpeted floor in the wintertime, and then gone to touch a doorknob, you know the basic principles that these devices are based on. These devices are based on two dissimilar materials that when in contact with each other, contact release, or just rubbing together, they generate an electric charge, a voltage difference. We can harvest that difference and use it to power devices. For instance, if we think of this in the application to the packaging industry, currently there's a lot of growth in the area of what are called smart or intelligent packages. These are packages often with devices embedded in them that require the use of power to run them. And so our work is focused on the development and optimization of a device that generates that power that could feed that smart package. So let's take, I have one of these right here. This is an example of just a sample of a scaled down version of what we're considering. And you can see the two different materials. These are, it's attached to just a common corrugated board. One side has a metallized film on it, and the other has just a polymer film, in this case Teflon, on it. So there are two dissimilar materials that when in contact with each other, either rubbing or contact and releasing, if something's bouncing up and down, they will generate a voltage difference, and we can harvest that. The application for this, if you could envision a device like this, but much larger, and we'll take this pallet, this unit load, for instance, sitting on a pallet, between each layer of these cases, we could have one of these devices. And as this unit load goes through the distribution environment, transportation by fork truck and loaded into a truck, transported to a rail hub, into a rail car, and shipped potentially across the country, back into a truck, handled again by a fork truck, all of that motion that provides input to the products would also be exciting these harvesters that we could use to generate electricity and power these smart packages, these smart intelligent devices. Those forces that we experience when we ship our products throughout the distribution environment are forces that, from a packaging science standpoint, we're trying to protect our products from. These devices would be using those same forces, harvesting them for the purpose of generating electricity. But potentially our device, and the presence of this device and how it's designed, being between the different layers, could actually kind of absorb some of that energy or mitigate what gets transferred to the product. So we'd have a double benefit, right? We'd be generating electricity to power smart devices, but at the same time, we would be lessening the input that gets transmitted to the product, thereby making our products increasing the chance that that a product could survive being shipped through the distribution environment.